Okay, guys, so welcome to the day one session on cloud performance engineering in DevOps. Uh, and this is going to be the day one. So, yesterday we went around demo and we just introduced the course about the course here, and we understand how we're going to go about the course, how we're going to plan the course. And I'm going to just talk about more about the course and the outline about the course. And if you guys have any questions on that, you can ask that. So to get started, I'm gonna start with the first topic, the cloud, the computing. That's the first thing we're gonna discuss about that. We're gonna start our discussion around that, and we'll be starting from, as I mentioned yesterday, that all the topics is gonna be from scratch, right? So I don't expect my audience to have any prior knowledge of cloud. I just want my audience to be from IT background. That's the least expectation I have. So that if I just talk about some like IP things like that, port, I just expect you to understand that. Apart from that, I don't have any. We don't have any prerequisite knowledge to have. And everyone would be creating an AWS account. I'll be guiding you through the process. It's very straightforward. We will create AWS account, and I'll be demonstrating everything in the account. I have an AWS account myself. Let me just log into that. We'll start from very basics. How do we log in? Like when you log in, you get two options. Either you can log in as the root user or you log in as the IAM user. Like C, you can log in as the root user. I'll talk about that. What is IAM user? So IAM is one of the services where you create users. So I've created a user of this name and I've created a password. So I don't log in as the root user. Root account is secure. I'm going to also tell you how do you do multi-factor authentication for your root user or your IAM user so that your account is super secure. So everyone would be having this account created, and I'm going to demonstrate each and everything here. And it's mostly practical session. I would be just PPT is just for the reference, just for me to understand that I don't miss any topic. But I'm going to show you everything mostly in this console until I'm talking about the cloud. Right. So that's how we're gonna go about the topic from very basics, how to do your budget setup, about the cloud concepts, very basics. When I say cloud concepts, you should understand what is a high availability mean, what is a disaster recovery mean. If I say scaling, you should tell me that there are horizontal and vertical scaling, right? So what is the difference between horizontal and vertical scaling? For high availability, what to go with, to go with vertical scaling or horizontal scaling. These are very important topics from a performance point of view, because see, end of the day, I understand the meeting the performance SLA response time throughput is your end goal, and within the resource under, like, you should have the optimal resource setup, so that you don't consume cost, unnecessary cost, right? Apart from that, you need to also look into how your components or the servers are deployed in cloud. You should always make sure a performance engineer is also expected to understand how do you achieve high availability, how do you set up DR so that your application is highly available. So performance is one thing, and having your application highly available is also an important parameter which a performance guy needs to understand. I do see one question here from Naresh. There's a lot of disturbance in the audio. Uh, so Naresh is observing some disturbance in the audio. Is anyone else is feeling the same way, or for others it's all good? For Ravindra, it's clear. How about others? The person who just unmuted was having background noise. I'm not sure who was the person. Guys, please confirm if I'm loud and clear and there is no background noise. But I don't see any background noise from my side. Test, I don't know who is test. Test is having a lot of background noise. I request test, the person with test, not to unmute. Not to unmute. Test, please go on mute, please. Yeah, thank you. Yeah. Guys, please confirm if uh, things are good to you. I'm loud and clear. There's no background noise. Please confirm that. All good?
Yes, Roshan.
Okay, perfect. Okay, so thank you. Thank you from me. Okay, so we're gonna understand. So the performance SLA is one thing. The response time and throughput is one thing, and you need to also make sure that the performance engineer responsibility to make sure the system is highly available. How should be the architecture? How many servers you should? So you need to first understand what is AZ, what is availability zone. Availability zone is like a data center, right? So how many availability zones you should have, what is the region, what region comprises of, and we'll talk about, we will get our understanding from that. So from an architecture point of view, so that your system is highly available, and when you should consider vertical scaling, when you should consider horizontal scaling, we'll talk about that. And we'll go about different AWS services like IAM, EC2. We'll talk about that. EC2 stand for Elastic Compute Cloud. IAM stand for Identity and Access Management, where we create users in one of the security services in IAM. It's fine if you're not able to understand that. I'm just briefing about this. Anyway, I'm going to talk about that in detail when I'm talking about a particular topic. I'm gonna talk about how do you provision an EC2 instance, a server in AWS cloud, and all the performance aspect from point of view. When I talk about the storage services, the different storage services that you have, and how performance play a role when you go with selecting EBS, EFS, and S3. From the cost optimization also, see, when you work in cloud, cost optimization is also a performance engineer responsibility. You should you anyone in the organization would reach out to you to just to make sure to configure so that the cost is optimized. You should have in not many servers or only the required number of servers deployed in production, and that too with a good configuration. The server utilization should not be underutilized. What is the point if of running a workload when your CPU utilization is always 20%? So I can definitely say that you are oversized your application, right? So you need to also think from a cost point of view. In the cloud, cost is the top priority because every month, trust me, uh, thousands and hundreds and thousands of dollars a company pays to cloud service provider. If your workload is deployed in AWS, your companies pays a lot of money. So the cost is the top priority, and who takes care of that? The performance engineer responsibility for the cost optimization. Performance, keeping the cost in mind. You should not oversize the server, you should not undersize the server. So benchmarking and doing performance testing to benchmark it so that you don't oversize your application or undersize your application. uh, right? So considering those things, we'll talk about that. We'll talk about database services that AWS has. We'll understand that with coming to the cloud, you don't have to think about uh, installing a cloud, installing database. It's all about managed database. I'm sure you guys have must have been working on different databases, Oracle, Microsoft SQL Server. Someone will be working in NoSQL databases like MongoDB or Cassandra, right? In AWS, it's all about managed service. You don't have to install and manage and patch your database. You have to only focus on the app optimization. That's what you need to focus on. Application optimization, app optimization. This is what you need to focus on. The installation part, configuration part is so easy. Auto scaling, you don't need to worry about disk getting utilized. You just need to check the option auto scaling, and this would get auto scaled. We have a lot of good features in cloud, and this is where everyone is looking for this, because the cloud service providers are doing a tremendous work in automation, in automating a lot of mundane tasks that we do on day-to-day basis. And that's why we need to look for the opportunity to upgrade ourselves, because expectation has changed from a performance engineer. If you talk about 4 years before, if you're doing a performance testing using any performance testing tool, Jmeter, LoadRunner, if you know some analysis, how to take heap dump, thread dump, and analyze it, it's all about that. But now the expectation is not just that. You need to understand cloud. You need to understand microservices, Docker, containers. If your application runs on Kubernetes, you need to know that as well. Different aspects of Kubernetes, you need to understand Kubernetes. On top of that, you need to also talk about performance part of it. How can you optimize your application better? And from the cost point of view, these all things come into picture now because of this transition what we are going in IT industry. And this is where all these topics, which is part of this course, is going to be very helpful to you. Right? We're going to talk about VPC networking. Uh, it's one of the very important topic. If you want to understand the architecture, how the how the software, your application is being architected in cloud, it cannot be done without VPC. VPC is the backbone. Once you understand this VPC, you would know how things are working in a cloud architecture, how things are connected. We'll talk about different serverless services, Lambda, API gateway, SNS. We'll talk about that. We'll talk about cloud formation brief. We'll understand one of the very important topic about the load balancing in auto scaling group. A performance engineer, if you say that you have worked in cloud, I can just ask one question and I can check whether you have worked or not. By just I'll ask you simple question about load balancing and auto scaling group, right? One of the very important thing, because we are in the cloud, you're expected to automate the scaling. Either you're doing a horizontal scaling, you need to automate that process based on certain criteria, because cost. So why we're talking about auto scaling? What is going to get impacted? The cost is going to get impacted. If you do auto scaling, right? If you do auto scaling, you don't need to servers. You don't need to run more servers. I'm going to give you one example, and you will understand by that. Let me just give you one example. Let's say you are running on one application, and let's say you know the workload. Let's say from 8 a.m. To let's say 10 p.m., 10 a.m. morning time, 2 hours. Let's say 100 users are accessing your application. Let's say that, and you have benchmarked your application, and you have understand that to run 100 users, you need two servers. Let's say that. I'm just keeping it simple, but yeah, but when I say two servers, basically you need to understand whether it's a web server, app server, or database server, how many servers, and if there are other components. I'm just giving you one example. Let's say two servers you require. And let's say you are from 10 a.m. to let's say 5 p.m. Peak business hours, you are expecting around 1,000 users. So you would require around 20 servers, right? 20 servers you would require. And let's say after 5 p.m. To let's say uh, 10 p.m. Uh, you don't have much workload. Let's say you have at least 600 users accessing your application, so you require 12 servers. Let's say that. I'm just giving the number. Let's say from 10 p.m. to next day, uh, 8 a.m. Next day 8 a.m. Okay, next day. Let's say it is next day. You have minimal application running into application, let's say 200 users, and you just require four servers. Right? If you are in on-prem, and if I ask you to just configure your application, configure your servers to support the entire day workload, how many servers you would require or you would provision? If you're in on-prem, guys, how many servers you would require to support the entire day workload? Anyone?
20.
20. Tommy, Bekna, yeah, 20. But we are in cloud. We are in the phase of auto scaling. Cloud is elastic. We call it cloud is elastic. Why do we call cloud is elastic? If in the cloud also, if you're running 20 servers all the time, what is the use? No, we are not going to run 20 servers all the time. And I'm not going to pay for 20 servers because in on-prem you have already purchased the service. So it's fine if you're paying because anyway you have purchased it. It's fine if you have it always up and running. But in the cloud, you don't need to provision 20 servers all the time. You can do auto scaling. You can leverage this feature of auto scaling, and you can auto scale your servers. For this duration, you can only pay for two servers. For this duration, you can only pay for 18 more servers. For this duration, you can only pay for 12 servers. And for this duration, you can only pay for the 4 servers. And if you think from a monthly point of view, from a yearly point of view, running the workload, you can save a lot. So all these auto scaling, all these features is always kept in the cost in mind. Remember, everything is being, the motivation is always cost. That is where, if you want to learn a cloud and want to just performance, cost and performance, you have to consider both things. Cost, performance, high availability, keeping your server application highly available, HA, robust, in case of any failure, right? Your application should support, should not be down, right? So you should always make this kind of architecture, right? And all these things are expected from a performance engineer. All these things, uh, architect a solution, but keeping cost in mind. You just cannot oversize the servers, and you cannot achieve high performance. If that is the case, I can only go for in-memory database. I can always go for in-memory IMDb, and my performance would be always better in milliseconds because I'm caching all my data. But that's always not the case because IMDb is very costly. In-memory database is costly. So you need to always consider the cost in mind while deciding on the architecture, right? And this is where this auto scaling is very helpful. We're going to auto scale things up, and we're going to provision only as required servers we need, right? Not unnecessary servers. You can understand that. In the cloud, we're going to talk about monitoring. We have one service called CloudWatch. We're going to talk about that. How do we capture different metrics? We'll get to understand that. Uh, we have some other services as well. That would be the first topic that we're going to cover, cloud computing. And what I'll be doing, since this Linux is going to be you need to be comfortable. I know if I ask in this forum also, 15 people have joined this forum. If I ask how many of you are comfortable in Linux, I'm sure 50% would say that you're not comfortable. I know that has always been the trend. I have been observing, and that's why I have incorporated this particular topic, because I have seen people are struggling because they have not been exposed. I would say they have not been exposed to Linux environment, because when we talk about right now the situation, containers, all the workload runs, we run in Linux operating system. Either they don't have the exposure, or they have not worked on it. That's why, and that's why we will talk about this Linux command line. I'll be sharing, while covering over this topic. I'll be sharing some self-paced videos which I have already recorded from a day-to-day session, and I would request you to go over this so that you can get comfortable with that, and we can talk about shell scripting, uh, for performance monitoring. How do you write shell script, right? We'll talk about that, because not every company would have the monitoring tool. Sometimes you have to write your own shell script. Let's say if I ask you that run a performance test, and your app server, web server, database server is all in the Linux, hosted in the Linux operating system. Run a performance test in Jmeter. You can happily run that. Most of you can run that, and then you can give me the response time. Perfect, good. But if I ask you, give me the CPU memory disk utilization of during the test duration of all the servers, because that's going to be a very important metric for me to understand, to troubleshoot, to analyze where is the bottleneck. If I ask you to do that, some of you can tell me few commands, but how would you plot this? I want that in a graphical manner, and I want some automated way to capture those metrics for the test duration. And that is where, if you don't have any tools, in Linux we have OS Watcher that can help you, but if you do not have any tool, you have to come up with your shell script, so that you can write your own script and you can collect all the metrics, right? We'll talk about that, and we'll talk about from very basics, how do you work in Windows. So I just always go about this topic considering how would you do in Windows. if you can perform a particular activity task in Windows, you can definitely perform the same activity in Linux. It's all about you knowing the command, nothing big. It's same operating system. It's so simple. I spend most of my time in Linux operating system than Windows. I just use Windows for just opening my laptop, and then I get to the black console always. Right? So that's how you'll be comfortable with that, right? After that, we're gonna talk about architectures. The idea is to understand the microservice architecture. We'll talk about that. Um, what are the differences between microservices and most application? We'll talk about that. And where do we host these microservices? We'll talk about containers, right? So that will take good 4 to 5 days, right? I'm gonna talk about different Docker, all the Docker common Docker operations. How do you create containers? How do you host microservices in these containers? And when you have a lot of containers, we need to orchestrate them. When I say orchestrate them, you would like to auto scale the containers, right? Based on certain criteria. So we'll talk about horizontal pod autoscaler, cluster autoscaler. How do you monitor all the containers that you have in Kubernetes world? We call it pods. We don't call it containers, we call them pods. We'll talk about that, right? And then at last, we will go about understanding how performance engineering and performance engineering fits into DevOps. What are different roles and responsibilities of a performance engineer in a DevOps? We'll understand that, and we'll talk about continuous performance testing in DevOps. How do you create a Jmeter job in the performance testing lifecycle? We'll talk about that, right? Using Jenkins as the CI tool. We're going to install all the commands. We're going to talk about Docker Hub. We're going to talk about Git. We're going to talk about CI/CD pipeline. We're going to talk about automated feedbacks. We'll talk about all these things, right? So that's the course, and that's how the course would flow. And the course would definitely take around 40 hours. And I can be, to expedite this over the weekend, I can be sending some self-paced videos to go over that for a few of the for the simple topics which is easy to follow. Uh, I'll be like, this is what I'm gonna share first thing, because I've talked about from very scratch. It's all about you going over them and practicing. So I can do that as well. So that's how this particular course would flow. I have shared this link to you guys yesterday. If you guys have anything about the course, do let me know. If not, we can get started with the course, with the first topic. Do you have any questions, guys? Anyone? I'm gonna wait for a minute if you have.
Actually, one question. So overall, how many days the complete course will be comprising of? Like 40 hours. So like 1 hour each day or something like that?
Correct. We're gonna meet 9 p.m. to 10 p.m. every day, right? So if you calculate that way, yes, it's gonna take 40 hours. But if you're considering
40
the
days.
40 days, yes, 40 days. If you go at the top, you would know. Let me just show you. So this course is for the around 40 to 45 hours. Yes, 1 hour every day, right? That's what we're going to meet every day on the weekdays, right? And I'll be giving you some time also in the weekdays for you to practice, to go over the self-paced video, so that you get enough, ample time to practice as well. So yes, it would take around 2 months. You can consider that way. And if I just give you to self-paced videos as well, anyway, I'll give you some time in the weekdays to go over them. Yeah.
Hi, Roshan. For this course, do we need to have prior knowledge of JMeter for this course specifically?
No, I'm not going to talk about Jmeter. Okay, I'm not going to talk about how do you do correlation and things like that. No, I'm just going to use Jmeter to automate, uh, create one job, right? I would just tell you how do you trigger the JMeter job, automated triggering of the JMeter job. So the JMeter knowledge is not required. I'm gonna just use JMeter tool to trigger the performance job, to create a performance job, and automatic triggering of the performance job can be done using the Jenkins. So that's what I'm going to do.
Okay, so can you also guide us to schedule a job by using LoadRunner, because normally most of the people use LoadRunner instead of Jmeter.
Okay. Anyway, but most of the people, it's not that case. Jmeter is gonna be the open source. But I can tell you, I can show you. It's all about one plugin in Jenkins. Okay. Right now, I can tell you. I can show you also. It's all about one plugin in the Jenkins. Once you understand Jenkins, you would know how easy it is. I can show you that.
Thanks, Roshan.
Yes, Sonal, absolutely. You would be given the recorded session on daily basis. So if you have missed any session, yes, you would have the recording with you to go over. Yes, absolutely, Sonal. Okay. Do we have any more questions? If not, we can start with the first top. Can we start?
Roshan, I have one
Yeah,
question here.
sure.
Just out of curiosity, I want to ask, are we going to share any interview questions like on these many topics? Those would be the interview questions from the most likely interview questions. Are we going to
See,
share any such document?
the entire topic is gonna be the interview preparation only. So whatever we are discussing, right? So whatever we are discussing in general, if you understand that part, it will be clear. Good. But out of that, after that, also, if you like me to share something, I can definitely share, or I can start my daily session with few questions, or start my topic with a question. I can do that. I do that mostly.
Yeah, that would be really helpful, Roshan. Thanks.
That's how I go about topics. I ask you a problem statement, and then only I will only answer that.
Okay, understood. Thanks.
Roshan, one thing, will you be sharing the old batch video recordings also?
If you need, yeah, we can share, but if you need the recorded videos, like all the recorded videos, because we'll be sharing on daily basis or as and when we'll complete the topic. But if you need everything in advance, we can share that. So that's not a problem.
Yeah, that will be helpful because so that we can during the weekends I can go through the
Yeah, yeah.
uh,
Anyway,
whatever
I
recording.
have plans. See, better to stick with the plan. Okay, just when you want to learn something, just get 2 months of time. Okay, at least 1.5 months. I can share the self-paced videos, my own videos. I can share that at the right time, and I can give you some proper time as well to go over them, because it's gonna be quite knowledgeful session every day, and you're supposed to practice later by spending 1 hour or so in your time after 1 hour of session. So it's gonna be very hectic. So yeah, we're gonna go with the pace. I know how to go with the pace. Yeah.
Okay.
Just someone with test has joined, and that background noise is coming. First, let me mute you. Better to mute you. Yeah, someone has joined with test. Background noise is coming. You're not audible. Test. I don't know who is that person. Okay. If we are good and if we have gone over all the questions, can we start now? Okay. I take
Yeah,
that.
yes, please.
Okay. I'm gonna wait 30 seconds for everyone to just complete and we can start.
Roshan, can you hear me?
I can hear you. Yeah.
Yeah. My question is, I'm new to performance testing, don't know anything about it. So how this particular course is gonna fetch me in going forward in
So
cracking the interviews and all
what is your expectation in the interview? What do you want to become?
to get a job in performance testing?
No, you should first learn Jmeter or any LoadRunner.
Okay.
If you're new to that, yeah, first do that. Yeah.
Okay, sure, Roshan.
Yes, one more thing. Not only before going to Jmeter, you should know the basic concept of performance testing.
Yeah, they would tell you like
Yeah.
when I say Jmeter,
Yeah.
I mean basic performance testing is Jmeter. Yes. With
I think
start.
Jmeter is a tool. Now,
Yeah, like learn
before that,
testing with to start with the tool. I think we are talking about the same thing. Yeah, I think he understood. Okay, I think we are good to start now. Okay, let me. So I've just one of my last batches. I'm gonna create a new kind of always do that. I'm gonna create a new drive for our batch March or April, I would say this time, and I'll be sharing these PPTs as and when we are completing the topics. Right. So let me start with the first, which I'm going to talk about cloud computing. Okay. Okay. So to get started, right, I want you to tell me what is your understanding of cloud. When you hear this word cloud, I want everyone to use the chat option to write one sentence. Okay, a few words, one sentence, whatever comes to your mind, the best you can define cloud. I want you to write that. Whatever your understanding is, please help me with your understanding with your definition. Yeah. I would like to go over them before I go about any topic or defining cloud and making the concept clear. Right. Yeah. Please, if anyone can help me with that, pay as per use model, Swami. Okay. Good. How about others? Accessing of data and computing services over the internet. Perfect. Good. Aruru. Yes, absolutely. Meghna answers services provided by company for building applications. Okay, good. Reducing the burden of managing physical servers. Reducing the burden. What does that mean, Naresh? So, burden means what? Of purchasing, right? Burden means purchasing. You mean to say, Naresh?
the meaning of modern, I think, no need to bother about the hardware side. I think.
You no need to purchase this hardware, right?
Like I mean to say, no need to go for procurement and no need to do like daily housekeeping and all, and having a
Perfect.
infra guy
Perfect.
always.
Yes, absolutely, absolutely. Yes, virtual server. Yes, almost. I think infrastructure as service. Someone has mentioned infrastructure as service. That comes under Ravindra. That comes under service model. Uh, then, if you have infrastructure service, so first of all, I can ask you a cross question, Ravindra. What is infrastructure service? What is your understanding? So that definition, that has a definition. Infrastructure as service. Okay, I think all of you reducing dependency on managing physical servers and focus on business. Exactly. So one has absolutely right. So you guys are all talking the same thing, and you guys all asked in the right way. Okay, and that is what my understanding is. Right. Even when I say cloud, right? The way I define cloud, something, the servers which I don't own, right? The way I define it, the way, and I want everyone to take this definition, understand this, that the servers are the resources which I don't own. Because in on-premise, when you set up your on-premise, let's say, when you set up your on-premise, basically you set up this, you set up one data center. You have to procure the land, purchase the land, you have to build one infrastructure, the building, the cooling mechanism, you have to invest a lot. You have to invest on the security. You have to purchase the. You need to have multiple of many options like the multiple power backups, multiple network switches, multiple internet service providers, multiple. Because if one fails, you can't make your server down. The power supply has to go. So there has to be multiple power supplies, generators, cooling mechanism. You have to purchase all the servers that will generate a lot of heat, right? A lot of storage services, a lot of servers wired, room full of building full of servers. That's what we talk about on-premise setup. And even right now, a data center would look like this. So what is my understanding of cloud? That someone else has set up this data center. For example, AWS or Azure, Microsoft or Google, GCP. They have set up these data centers across the globe. And what we're gonna ask them, that boss, can I use few of your servers? Can I use your servers? I'm gonna pay for that. That's fine. They're gonna charge me. That's absolutely fine. Pay as you go. Someone mentioned, right? So I'm gonna only pay for the servers or the services I'm gonna use it. For the compute time, for only for the test for timing duration which I'm gonna use, I'm gonna pay only for that duration. Would that work for you? I'm gonna ask them. They would say yes, I'm happy. Please do that. Even they would tell, I'm gonna charge you for the only for the one you use it, and for the compute time you use it. So someone mentioned the definition, the access of hardware and software over the internet. That definition is bang on the target. Someone mentioned that, and that's the definition is all about. I'm going to make use of those servers out there in some data centers remotely located. I am somewhere else. Those data centers are across set up all across the globe. Some data centers are in Europe, some is in Singapore, some is in US, some is in Australia, New Zealand, just name it. Across the globe they have it. I'm gonna sit remotely somewhere else. They have given me a console, right? Or they have a CLI also, and I'm gonna using remote just by the internet connection. I'm gonna provision servers there. How cool is that? Just think of this: that you have purchased, you're going to provision. You're gonna just feel it that you are going to own few servers here by remotely. You're gonna access the hardware and software over the internet. You are nowhere close to this location, nowhere close to this location. You are very much far, but you can provision server. You can run your own workload. That's how it is. That's the cloud for you. So someone else has set up a data center for you, and you're gonna just approach them and you're gonna ask them, can I use few of your servers? I'm gonna just use it for rent. I'm not going to purchase it. I'm like a rent. I'm gonna pay for it. Just give me few servers and keep it all always up and running. There has to be a SLA, or I would say the mutual understanding agreement has to be signed up, that if you do not keep your servers up and running all the time, you're gonna pay me fine as well. And they would agree. Yes, I'm ready to pay you fine if I'm bringing your servers downtime. If you're observing more than this, they're gonna give you 99.99% availability, right? They're gonna write a mutual consent, and you're gonna talk to them, and they would agree to make your system highly available all the time, and you're gonna use it, these servers on rent, right? And you can run your workload. If you need more servers, you can get more servers. If you need storage services, you can get it. If you need server for database, you can get it. If you need other services, you can get it. And that's what we're going to learn in this cloud, right? That is what understanding is. Your understanding should be of the cloud. So just to when I talk about the on-prem, right? So you have to set up everything. You have to set up the data centers. You have to talk about the networking. You have to set up that. You have to do the storage. You have to purchase all the storage devices. You have to purchase all the servers. You have to purchase, procure. Set up the data center itself is the costly part. It's not about just the servers. It's about land, legal aspects, security, cooling mechanism, so much cost affair. And back in That was the problem back in 1980s. If you have a business idea, if you want to run a software application, you didn't have any other option but to set up your own data center. But now, if you have a business idea, few bucks in your pocket, you can build your own application, run the workload, and generate revenue. That's simple it is, and that's how this IT is completely transitioning now. It's so easy to create your own application, right? You have to do the virtualization when you purchase the servers. You have to install the virtualization software yourself, so that you can create virtual machines. Then you have to install the operating system. You have to purchase the licensed version of operating system. You have to purchase the databases licenses. So you have to take care of the security. Then on top of that, you have to deploy your application. All these things you have to do when you set up your own data center. Legacy enterprise IT, legacy IT application. That's how it works. But we are in the phase of cloud now. We don't need to purchase everything. We talk about different service models. We talk about different service models like infrastructure service, platform service, software service. We're going to talk about that. What we own it, how much we have the control over. So, fine. If we don't, I understand we are not purchasing it. So, can't we have the control? Can't we ask for the control? Can't I decide on the operating system? Yeah, you can decide on the operating system if you're going for an infrastructure as a service, right? So we'll talk about service models and how much control you can have, right? In the service models, we're going to talk about that. So so how things were done before cloud computing. This was the setup, customers owning all the hardware and other components. That's how you have to own everything, all the hardware and other components to run applications or programs. That's how it was. But now in the case of cloud, no, it's all about accessing the same kind of hardware or same kind of application through the internet. That's the cool it is. That's the cloud for you. And why do we need cloud computing? The most important part, cost reduction. I cannot invest so much. I cannot purchase everything. What if my business does not run? I don't need these servers. Where can I sell these servers? Where can I sell this software? No one would buy for me. It's gonna waste. I'm gonna go on expenses, unnecessary costs. What if my business does not run? If my business does not run, fine. I'll stop using it. At least I will stop these billings. For the POC purpose, also you can use cloud. If you think setting up your own data center, if your business requirement is as such, you want to keep very much secure application, host your application in your own data center, you can go about setting up one. Right? But you can do a POC with the cloud. A lot of options, scalability. You can scale. You can have as many servers you require. It's not like in on-premise. Today, if you have 5 servers, tomorrow if you want 50 servers, you have to purchase it again. No. If you want 50 servers tomorrow, you can just get it by one click. You're going to pay for it. That's fine. But you can get it without any hassles. They have all the servers you need. That's how easy it is. People use cloud for the disaster recovery. I have seen customers, they're using on-premise as well, and for disaster recovery, they're going for the cloud. They don't want to set up their own on-premise setup. They're going to cloud now for disaster recovery. Our data is secure. We're going to talk about a lot of security options in cloud. Absolutely, data is secure. Right? Automatic software updates. All these features are enabling us. Why do we need cloud computing? And why we are able to enable this? Because when I talk about the virtualization, understand this was a big revolution back then. Virtualization, when you have physical server, how do you create VMs? You install something, let's say if you have a 3-tier application, web server, app server, database server, you run your workload, but you install those things on a VM. But how do you create VMs? Without virtualization, you cannot create VMs. So on the physical server, it's a full rack. When I talk about the server, it's a full rack. You get thousands of cores, thousands of memory in it. But how do you distribute, let's say, one VM for 4 vCPUs, 8 GB RAM? How do you mention that? You do virtualization. And how do you do virtualize? So this is your physical server. You install something called hypervisor or virtualization software. One of the virtualized software is called hypervisor. VMware is a leader in that. VMware hypervisor, VMware virtualization you can install. And then you can go about creating VM. This is VM1, this is VM2, this is VM3. All the VMs require separate operating system. Right? And then you can run as this is the web server, this is app server, this is the database server. They are doing the virtualization for you. That's why you can create VMs. They are doing this for you. Till this point, even if you're going for infrastructure as a service, till this they're gonna own it. You don't want to own this. This is a big headache because you're going to cloud because you don't want to manage all this. You don't want to purchase all the servers, software to do the virtualization. You don't want to do that. That's why you're going to the cloud. We're going to talk about the service models, and you're going to understand different service models in some time. So when I talk about the cloud, the simplest definition which I like personally is this. Cloud computing is computing based on the internet. All you need is the internet. That's all you need. The use of hardware and software delivered via network. This is what you do in cloud. You don't own anything, but you can have everything. On-demand self-service. On-demand self-service. When you need it, you will get the servers. They have something called self-service, a cloud console which I showed you. What is this? Self-service. When you ask for servers in AWS, you don't need to call them that I need some servers. They're going to tell you, go and create an account here. Go and create the account here. And you have all the, and they have enabled all the options for you to get anything done. If you want your server in Singapore, you can get it. If you want your Singapore in Cape Town, you can create it. If you want Singapore servers in Mumbai, you can get it. If you want your servers in Frankfurt, Ireland, London, you can get it. Wherever you want, these are all regions, they have it across the globe. 28 regions, they have it. 84 availability zones, they have it. Data centers, 84 across the globe. And they're building up more and more. Not just AWS, Azure, GCP, everyone is building. It's growing, right? That's how it is. So on-demand self-service, broad network access. Yes, everything, all the things would be monitored. Everything would be monitored. Whatever you use is going to be monitored. And they will give you exact time, how much time you have used it, how much you need to pay, the breakdown of everything. You can do rapid elasticity. If you need to today, if you're using 2 servers, your application work, your business is small. Tomorrow your business has grown, you need more servers, just get it. It's about was clicking one option. Automatic scaling, you can do it. Everything is automated. And why we are able to do all these things? Because of this virtualization and automation. They have automated everything. If you want to understand the best automation around you, you should look at the cloud service provider. Understand the level of automation they have done it. They have given a self-service, and you can create wonders. You don't need to be near to you don't need to go to near to the data center to create servers, to run your workload, to use any service. You can be somewhere remote and you can do anything. What a person sitting in the data center would do, you can do it from remotely also. That's the level of automation. So the cloud means virtualization and automation. It's all about this cloud. So that's the definition of the cloud. You have a lot of advantages. Capital expense, trade over capital expense for operational expenses. Yes, because you're not going to invest, not going to purchase all the hardware. Yeah, you don't own hardware. So reduce total cost of ownership and operational expense. We have reduced that. Benefit from massive economies of scale. You can get as many servers you want. You can do auto scaling. You can again optimize the cost. If you benchmark your application better, if you know the workload better, you can optimize that. They would give you the actual measured usage, stop casing capacity. You can if you can auto scale as accurately as possible. You don't need to waste resources. Speed and agility. Stop spending money running and maintaining data centers. Yes, because they are doing it for you. That's their business. And how AWS has evolved, this guy, Jeff Bezos, he was setting up one data center for his own website, Amazon.com. And he ended up creating this AWS because he thought whatever the data center he's enabling, he can just go on one more step and he can enable the entire infrastructure for the entire world. That's what this AWS was created back in 2008. And that's why it's leader. All the other cloud service providers, they have started quite late, around 2014, 15, 13, 14, 15, 5 to 6 years. It has created before. And EC2, S3, SQS were the first three services. I'll talk about that in some time. Go global in meters. Yes, all the advantages of cloud computing. All these are the problems solved by the cloud. Flexibility. Today, if you're running your workload in 4-core, 16 GB memory, let's say that. Tomorrow, if you want to change the workload, if you want to run a workload in 8-core, 32 GB memory, that's what you think is going to be more optimal for you. Run it. You're not going to pay for 4-core, 16 GB RAM now. Cost effectiveness, pay as you go. Someone mentioned.
I have one question. The core means is a CPU means, right? One core means on CPU part, hardware level.
One core is one CPU. Yeah. Pay as you go model. You can only pay for what you use it, not what you don't use it. No, you're going to pay only for what you use it. Accommodate larger loads by making hardware stronger or additional nodes. You can do that. Elasticity, we're talking about that. High availability, you can set up your architecture in such a way that your application is highly available. You deploy your application in multiple AZs, multiple availability zone, multiple data centers. We'll talk about that. How do you do that? How do you make sure your application is highly available, durable, fault tolerance? We'll talk about that. We have a best pillars of architecture. We'll talk about that. So these are all the problems solved by the cloud. When I talk about the service models, right? These are the service model: infrastructure service, platform as service, software service. So you're gonna go to the cloud service provider. You're gonna ask them, I'm gonna use you, but they're gonna ask you what all you want to control, what level you want to control. No, you tell them, no, I want to have the control over my operating system, what I run. I want to control over the. So they're gonna give you three options: infrastructure service, platform service, software service. So the amount what you have control over in the on-premise, you have the control over everything because you purchased it. You own everything, so you have control over everything. But in the cloud, when you go infrastructure service, you don't. These things, the data centers, networking, storage, servers, virtualization, going to manage by the cloud service provider. And as a customer, you're going to manage this operating system. You're going to decide that. What databases you're going to run. You're going to decide that. What security would be set up. You're going to decide that. Well, it's your application, your database, your application. You're going to decide all these things in the infrastructure service. When you use cloud as a platform as a service, basically you're going to ask them that I don't want these hassles. You take care of these things as well: operating system, databases, security. You just give me the runtime. I'm going to just deploy my application. I'm going to run the code. I'm going to write my code. I'm going to focus on my application development only. I'm going to run the code, write the code, run the workload. You give me the entire platform. If you are writing the code in Java, they are going to give you the Java platform, Java runtime to write you to enable you to write the code. They will give you the platform to deploy your code. They're going to enable you to run the entire workload. You're going to simply go there and upload your code. So they would give you those infrastructure. That is platform as a service. When you go software service, you don't have control over anything. Like the likes of Gmail, YouTube. Currently, I'm using Google Slides. What are these? They are software service. I don't know. Do you know where when you open YouTube or when you use Gmail, do you know where the servers are deployed? What operating system they have used in the server? Do you even care about what security services they have used? No, you don't care about. You use software service. That's this SaaS. I'm using Google Slides right now. I don't know how Google Slide is, how Google Slide have, which language they have developed with Google Slide, or which server they have deployed, region they have deployed. I don't care. I don't know. As a user, I don't have control over those things. I'm just using the service. Currently, these things are free. That's fine, but they can charge also. That's what the software service do. These are different service models we have. We have one service here in AWS called Beanstalk. Beanstalk is one of the perfect example of platform as service. If I just show you the Beanstalk, what it gives you, you can write the code, write your own code. That's perfectly fine. What it would enable you, you can create your own application. You can create application, and what you can do, you can just upload your code. As simple as that. You can come here, you can mention the platform you are running the code in, let's say Java or Python or Ruby or whatever you want. Let's say you have developed a jar file, let's say that, and you want to run in a Tomcat. You can select the Tomcat and just upload your code, jar file or war file, whatever you want. Just upload, choose file from a local machine, upload it, and it's gonna run. As simple as that. That's the platform as service. They're gonna give you the entire platform to run your workload, to run your application code. Beanstalk is the perfect example of a platform as service. Right? And when you create, we have something service called EC2, where you create servers, right? Elastic Compute Cloud is one of the first AWS services they launched with. When you create servers here, you basically have the control over the operating system. So EC2 is one of the services that's the perfect example of infrastructure as a service, because it's you gonna decide what operating system is gonna be in this EC2 in this machine. You can just launch instance and you will get all the options. You can select the operating system. In Amazon AWS, they call it AMI, Amazon Machine Image, as the operating system. You can select any of the AMI. You can go about selecting Mac OS or Red Hat or Ubuntu or Windows, whatever you want. And you can have the server, you can run your workload, you can install whatever you want. That's the example of infrastructure service. So yeah, that's the service models. Then we have something called deployment model. We'll talk about that maybe tomorrow. Yeah, we are 2 minutes over the time. So that's all for today, guys. If you have any questions, do let me know. We are done for the day.
Is there any free instances EC2 can able to create for the any AWS account?
You can create, absolutely. I'm going to guide you in upcoming sessions. How do you create AWS account? And AWS has something called free tier. Okay, you can create AWS account for 750 hours of compute time is free. 1 year
Per month, right? 1 year.
750 hours of 750 hours in 1 year.
Okay, for 1 month.
What?
Yeah, please.
It's a free
750 hours.
750 hours. For 1 year, it's going to be free. Either use 750 hours, either you can consume 750 hours in a month also, right? 24 hours, you can do 24 hours into 30 if you use. So it's going to be 70-20 hours. If you run 24/7, it's going to consume you in 1 month also, if it's possible, if you can just work that much, but not possible, right? So 750 hours in 1 year or 1 year, whatever, it's free when you create this AWS account, but you have to create T2.micro also, only T2.micro, then only it's free. If you select any other
micro means, what is the meaning of micro?
I'm going to talk about it. I'm going to talk about it in upcoming sessions in EC2. I'm going to talk about it. It's an instance type.
Okay.
Okay, I'm going to talk about that. So yeah, everyone would be having this AWS account created. Don't worry. I'm going to tell you when to create. So yeah. Do you have any more questions, guys? Okay, thank you. I take the silence that we're all good. So thank you everyone for connecting. We'll meet tomorrow. Thank you.